Hello students. Students of ICSE and CBSE boards, you people are going to face the board exam very shortly, within 2 more months. Still you people have doubts when it comes to numericals problems in current electricity. Here I am going to cover in a very short video the combination of resistances, and then in the upcoming videos after this I am going to help you solve several numerical problems on current electricity. So let's proceed. So here I have drawn three combination of resistances. Let me start with the series combination. When do you say that the resistances are in series? What happens is that when you get these resistances in a combination like this, so that the source of electricity that we have here, it can be a cell or it can be a battery. Here it's the key or the switch, and here we have combination of cells that we term as a battery. And as you know, the current is from the positive terminal to the negative terminal. So what happens is that current I, since it is a single path, so current I, when it comes at this point, it has only one line, you see. So current I, whether the resistance is more or the resistance is less, it has no other option but to go along this line. The same current goes through R1, R2 and R3. That is what you have to keep in mind, that when the current in the resistances are same, then the resistances are in series. Okay, so current I, it has no other path than this line. So I current flows through R1, R2, R3, and then the circuit gets completed. Is it okay? So in such series combination, the equivalent resistance, R equivalent, is R1 plus R2 plus R3. All right. So through R1, R2, R3, the same current flows. Then what is the difference? The difference for R1, R2, R3 is the potential drop, the potential difference between these points. One is V1, the other is V2, can be termed as V2, the other is V3. And from Ohm's law, we know V is equal to IR, isn't it? From Ohm's law, we know V is equal to IR. So V1 is I into R1, V2 is I into R2, and V3 is I into R3. So there is a division of voltage. This V1, V2, V3 comes from where? It comes from the supply voltage. The supply voltage, that is the EMF of the cell. So this cell, which has V as the potential difference that it can provide, this V is equal to V1 plus V2 plus V3. Okay, so we have a series combination of resistance where the equivalent resistance is R1 plus R2 plus R3, and from Ohm's law, as we know, V is equal to IR, we have V1, V2, V3. So what does divide over here? Here the voltage gets divided. The supply voltage V from the source gets divided against, I mean to say about R1, R2 and R3. All right. Okay, then we proceed to the parallel combination. When we say that resistances are in parallel, here also when I draw a supply, that means I'm drawing a circuit again. This is how you draw the circuit. If you have to provide an ammeter, a simple circuit diagram, the ammeter always has to be in the series. Okay, so if you want to put an ammeter, you can provide it anywhere here or here or here or here. Okay, now let's first learn the combination. Here the resistance is R1, R2, R3. For you, I have taken a very simple topic today. This is the key and this is the battery. Here, this is the positive and this is the final negative. And let me say here the potential difference that it can provide is V. Now, this point and this point, they are the same points. You have not provided any resistance, any other electrical appliance here other than the key. So, the effective potential difference between points A and B is V. Now what happens? If the total current in the circuit is I, when I reaches this point, current over here actually sees three paths and hence gets divided. So current gets divided here into I1, I2 and I3. So over here in a parallel combination, the total current I is getting divided into how many parts here? Since there are three paths, we are having I1, I2, I3. As soon as I1, I2, I3 reaches at this point, it again gets summed up and I gets completed. Okay, so this is the completion. Always in a circuit, you have to remember that the total current I, if it gets divided also, it will return back as the total current I over here. So what do we get here? We get that the potential difference between A and B, it is nothing but V. V is getting the V is actually getting the current to move in circuit in the paths R1, R2 and R3. Okay. So what we have is here V is equal to I1, R1. V equal to I2, R2. And again V equal to I3, R3. Because you see this A is nothing but this point. This B is nothing but this point. So in a parallel combination of resistance, about the parallel combination, the potential difference remains the same. So what does get divided? The current gets divided. Is that clear? And the combination of resistance has an equivalent resistance as 1 by R1, 1 by R2, 1 by R3. I can teach you simpler methods also in circuits which have more resistances so that you can understand. All right. Okay. Now comes the mixed combination. Why do we call this a mixed combination? In mixed combination of resistance, you see, if I name this as R1, R2, R3 and R4, what do we see? We see if current reaches this point, the same current goes through R1 and R2. Isn't it? So, same current through R1, R2 means R1 and R2 are in series. Alright. Now, this current when it comes at this point, it sees two paths and hence gets divided. So, R3, R4 are in parallel. R3, R4 are in parallel. Alright. Again, it comes here and gets completed. So, I current goes through R1 and R2, comes here, gets divided into I1, I2. That again gets together and becomes I to complete the whole circuit like that. So, what will be the final resistance? Here, R1 and R2 are in series and you are going to write it like this. And for R3 and R4, we have 1 by R dash is equal to 1 by R3, 1 by R4. And finally, R dash means the equivalent resistance for this little parallel combination. You'll do the LCM and you'll find R3 into R4 by R3 plus R4. Okay. So, the final equivalent resistance is a series combination of R1, R2 and R dash, isn't it? When we do equivalent resistance means we are combining these two to form one, and that one over here is R dash. So as if R1, R2, R dash, they all are in series. So What we write here in mixed combination, the equivalent resistance? It is R1 plus R2 plus R3 into R4 by R3 plus R4. So, it's a very short video that may help you to understand the resistances and their combination. So, I'll tell you to go through your book, whatever book you are following, NCERT book or any other ICSE book or concise, whatever book you are following. There you will find all these circuit diagrams where you can find out which all resistances are in series or in parallel. I think you liked it, and after this, whatever video I'm going to upload, there directly I'm going to help you solve problems. And we are also going to discuss the potential drop across internal resistance. Okay? Okay. Happy studying.